Hello, everyone. Good morning to all of you. And myself, Sumit Maheshwari. I am a tech lead at Data Infra team Twitter right now, and also a Apache Airflow PMC and committer as well. And in today's talk, I will going to talk in brief about the Airflow present, and also going to talk about some of the Airflow's cool features or improvements which are going to come into into very near future, or some of them is already committed into master. So we're gonna talk about them as well. So to start with, we talk about the basics of Airflow, just like a 101 of Airflow for the folks who may not be aware about what Airflow it is and why it is being used at the first place. So if you go by the, I would call it like a dictionary definition. So Apache Airflow is a platform to programmatically author, schedule and monitor workflows. It's basically a workflow management system written completely into Python and been into open source community since the inception, or I think I would say 2015 itself. So the Airflow was originated at Airbnb in 2014, and then it made into open source by 2015. Airflow is basically the core concept of Airflow is basically workflows, or you can call them DAG, which is basically a set of directed acyclic graph, set of directed acyclic graph tasks, and it is written completely into Python, so it makes more, it makes the code, shareable, reusable, testable, and all of that Python features basically. And apart from that, Airflow is a a very rich UI basically, and that was the one of the main selling point back then. And I think it is still one of the major selling point for Airflow, and it has a decent CLI along with that. And the major part is that it has a very big and active and growing community at the moment. We can talk in brief about the growth of Airflow. So I took this comparison very recently and compared Airflow with one of the two competitors. Actually, there are a couple of more competitors like Spotify's Luigi, LinkedIn's Escaban, or Uzi, and a couple of more. But most of them do not even have proper, comparable stars to compare with Airflow. So I took Luigi and Escaban, and you can clearly see the difference that even though Airflow is pretty new in compared to both of these, in terms of popularity and active community numbers, it has surpasses them. And is still going on. Just couple of figures actually, like it has like more than 18,000 stars and more than 1,300 people who have contributed to Airflow so far. Um, there are more than 350 organizations which are officially using it. Actually, that unofficial number is even large, but we cannot comment on that. And recently, Airflow finished a 2-week long virtual summit called Airflow Summit. Successfully, there were like more than 50, like close to 50 talks, and more than a thousand participant along, all over the world attended that summit, and then response was fairly good. Also, if you talk about the active commits and all those things, and you can clearly see. I took this image from the GitHub, and you can clearly see that the code commits, is it's. I would say it's a at good scale, and even it's better compared to that early stage, which is 2015, 2016 scale, and it is growing day by day. And there could be a reason that Airflow 2.0, which is gonna be a totally like so many new features and lots of things going to change around the corner, and that could be the one of the reason that there are so many commit are happening and so many changes are happening at the Airflow at the moment. And maybe I'm not very much sure, but it could be because of this pandemic situation that that people have got some more time to work on the open source projects, and Airflow be one of them. Okay, so yeah, I think that's it about the present. I'm more interested in talking about the future. So I'm just gonna briefly talk about the AIPs. So AIPs basically is the Airflow improvement proposals, and they are the mechanism through which any big change, any big feature, or anything which actually changes the way it is get introduced, discussed, and implemented finally. And there are lots of AIPs in the progress right now, but there are a couple of AIPs I'm actually pretty looking forward to it. And some of them are already into the master of Airflow, but there are some of them are actually into very active development right now. So I'm just going to talk about some couple of AIPs like functional DAG, scheduler, HA, REST API, DAG serialization, smart sensors, and task groups into small sections. So the first one I would pick is the functional DAGs. This is tracked into AIP 31, and thanks to Gerard, Tomek, Evgeny, and Jonathan. And this feature is already, landed into Airflow. So before understanding functional DAGs, would like to understand. We have to understand what is XCOM basically and why they are used. So XCOM is basically a very unique feature in Airflow where you can actually pass the messages or basically small amount of data from task A to task B, or actually like so on, like task is and so many other tasks also. It's a very good for passing a small amount of data. And why? Because it works against a database table, and that database table has some limitation to the column size, and it holds the serialized data. So when you store some data, it serialize it. When you get the data back, it will deserialize it. It has very easy to use interfaces like task instance. TI is task instance basically here. So ti.xcom push to push any data, and ti.xcom pull to pull any data. It used very heavily into ETL pipelines because more often there was need about storing some information which is like more about transient in nature, and it just required to pass on the information from task A to task B basically. And to pass on that information, XCOM is used heavily. So what are the issues then? It seems everything is fine. Then the problem with the XCOM is that one has to write lots of boilerplate code around it basically, and you have to figure out how the information will flow. Logically, of course, you have to figure it out, but programmatically also you have to figure it out. Like how would I write code so that this guy will push the data and this guy will pull the data and all sort of stuff. So it's like understanding the main logic will become difficult because of this boilerplate code around. And the second one is the data is stored in database. So it is used only for a small amount of data. And if somehow or someday your task actually got pulled too much data or something like that, then it will create issues. So you have to plan accordingly, like what to do it. So let's look at example DAG in today's world without the functional DAGs, how it will look like. So this is a simple ETL job, and if you look at it here, you will see that there are three tasks. And the first task is basically just loading some data from some HTTP endpoint, and through XCOM push, it is actually pushing that data into the database. And then there is a second task, which is a Python operator, which is calling a Python function transform. And in this function, we are actually pulling the data from the first task and modifying and data and actually storing the data back into XCOM. Then there is a third operator, which is the email operator, which is basically loading this data from the second task and sending email content. And then lastly, we are actually binding the pipeline, and we are saying that okay, extract should run first, then transform, then load. So it works just fine, no issues at all. But with the introduction of a decorator called @dag.task, we can actually simplify this DAG a lot, and we can actually focus more onto the logical things rather than message passing things. So in this thing, if you look at the first task will remain the same, but the second task we don't have to actually define any Python operator here. We just say like @dag.task, uh, construct, and then it will automatically creates a Python operator under the hood, and also create a random name to it. Also define also OP key args and OP args for it. And finally, you can just write the method, assuming that you are getting the content. So if you look at this transform method, you are seeing that okay, the content is there, and then you basically work with it, and finally you just return that the output whatever you want to return. You don't have to worry about pushing into XCOM explicitly. And the another part, if you notice, there is something called transform then extract dot output. So output is another method which is kind of added to all the operators, and it will automatically get the XCOM data out of the XCOM, basically, like from the database, and do the deserialization and all of that. So you don't have to worry about that, and you should just call the extract dot output. And finally, the third one is like the email operator. And if you look at it, it is if you look at the subject and HTML content, it will it is working like it just got a dictionary from that function, right? It will it will this program will look like more like a Python script now, rather than a DAG where people has to think about that. Okay, this task are not running on the same machine and like not in the same Python runtime, but they are running into different runtimes, right? But this looks like that everything is running under the same Python runtime. So this is the way to simplify it. And also with this functional DAG, there is also work going on about custom XCOM backend, basically. So you don't have to rely on to the database. Actually, you can have your own, let's say, S3 or GCS as the backend, and then you can actually push and pull large amount of data as well. So that is also going on. There was a very nice talk done by Gerard into Airflow Summit on the same topic. So you can maybe go and check that out as well. So the next one I would pick is the scheduler HA. This is being tracked into AIP 15, and I think Ash and Caxel and maybe a couple of more people are working onto it. And this is not yet much. Like little bit history about Airflow scheduler. That Airflow is actually like by design it works. It launches only one scheduler, and it is supposed to be working only with the one scheduler. But actually, it has it poses lots of concerns. Like when you are running into the production environment, the first one is the high availability. What happen if the one scheduler goes down, and the second is the scheduling performance, like because when there are too many DAGs, let's say hundreds and thousands of DAG, the latencies will increase, and everything will start taking more and more time. So there has been lots of tries. I would say the couple of tries happened earlier to make it multi-tenant, like in the HA formation, basically. uh, in one solution, people actually run the multiple scheduler with the different deck folders. They don't run into the scheduler with the same deck folder. They actually split the task, but it doesn't give you the HA. The another approach is about the master and worker type of architecture, where basically I think it's more about active and passive architecture, where one scheduler will become active and it won't be the another one will be like sitting idle, and it will take over if the first one goes down. But it won't solve about the performance issue. Finally, like officially now Airflow officially is working onto it, and the approach they have taken is that each scheduler will be fully active, basically. So they will actually distribute the work among themselves. So this work could be like scheduling tasks or error handling or sending emails, sending the SLAs, all those things. So each of these DAG is equivalent to other. Sorry, each of the scheduler will be equivalent to the other one, and it will actually it will not only achieve the high availability, but it will also solve the performance issues. Also, this feature is actually relies onto the DAG serialization effort, which I'm going to talk later also. Because if you have relies onto Python files, it's very difficult to achieve um, the goal here. And this scheduler actually, like all the schedulers, let's say not only one, all the schedulers in this approach will use the database as the shared queue, and they will actually look and modify the objects uh, by taking actually log. So this whole thing is relies onto the database locking system. I know that this is more of internal of Airflow, so I will not go into the detail of it, how it works. But earlier, actually, there was scheduler. Actually, scheduler, the main process launches a process called DAG file process manager, and we actually that process actually launch multiple file processors, and the job of those processors to actually collect the DAGs for per file, and the scheduler will collect all of the DAGs from these processes via multi-processing pipes, and then schedule the things. Will be the bottleneck where it has to actually collect all the DAGs and take the decision. And a lot of time, has been spent in all those process. So the change here is like not, I would say, not very drastic. So rather than actually this processes, the child processes returning this DAX to the scheduler, actually they store the DAX to the database in a serialized format, into serialized JSON format. So scheduler do not, so the scheduler actually, now we have multiple schedulers. So each scheduler actually can look at that DAX table basically, and also can look for all the task instances it should run, and it can pick them with that, that take the log first into the MySQL, oh sorry, in the any database basically, and then pick it up. So it's not very drastic change, but it will solve all the issues we had. I think the only problem it might come is that may not be all databases support this locking. In that case, there could be another column into the DAG table, which will uh, denote like who has taken the log and who is working on which scheduler is working on it. So I think this is gonna be a big feature for Airflow 2.0. So the next I would pick is the REST APIs. It is being dragged into AIP32, and I think Kamil, Jarek, and others have worked on to it. Uh, there has been always a demand for REST APIs into Airflow, and we have actually some experimental APIs, but those APIs are not don't follow don't follow any standard pattern. They are not very well documented, and they actually breaks lots of REST principles as well. And then there are a couple of plugins also developed into open source apart from Airflow, out of Airflow, where people are actually running these REST APIs on top of a CLI itself. But that is also not very scalable solution, because CLIs may take a lot of time, because if you're running say Airflow backfill command, it will never complete. Actually, it will take hours to complete. So the goal here is that it should be easy to maintain, it should be trustworthy, extensible, and secure. Uh, so the approach which has been taken here is that we'll use this Open API 3 based definitions, which is a industry standard for designing APIs. Have used Connection, which is basically a Python framework to build REST APIs on top of Open 3 API specifications. And it will be integrated with the Flask app builder. So if you are aware about Airflow, then Airflow uses two UIs for now. So Flask based for non role based access control, and the Flask app builder for role based access control. So this library actually should be supported with both the UIs. I think in the Airflow 2.0, we are dropping that old UI, but I think this feature is already must. So I hope it should be compatible with both of them. And right now, the Airflow APIs are not authorized, I would say. So if you can hit the Airflow UI, basically you can actually execute the API as well. So with this change, this API will be also be access controlled, and they have actually introduced a new API, new RBAC can API access for the same reasons. So these are just list of some couple of important APIs, and this is still under development. So there are more and more APIs are actually being developed, and it will also create a path for any developer to come forward and actually add any missing APIs in future also. So a couple of important APIs are around, like the diagram, the task instance, variables, XCOM, connections, monitoring, and the pool. All kind of these APIs were always sorted by the community, and we are glad that it's finally here. So this is also another important feature, and I think it will this will be the base of many other feature enhancements for Airflow, and this is the DAG serialization. It is being tagged into AIP24, and Ash, Kexel, and Zhou Feng are working onto it. And sorry if I miss more people. So I will talk about briefly the problem, why it is required at the first place. So right now, Airflow has the three major components. We call it like web server, scheduler, and workers, and they all have to the parse the same Python file again and again because they all expect that all the DAG files should be available at certain location, which we call DAX folder. At under the DAX folder, this file should be available, and all this process actually parses them. So scheduler, let's say doing the loops into every 1 minute, it has to parse that file every 1 minute. And web server also like lots of worker threads basically. They also parses that files again and again. So a lot of resources actually get wasted in this process because same thing you're doing like multiple times, like I would say. And the another point is like it makes it very hard to sync the DAG across the system. Let's say if you updating a DAG, and let's say I have two tasks and I add another third task, and if I have to sync it now, and I have to use some kind of way to sync all the three machines at the same time. If I don't do that, there might be chances that there has been some mismanagement happen in between, like some task the web server sees, scheduler don't sees it, or vice versa. Like scheduler can pick up a job and pick up a task, schedule it, but the worker will not find the task that it is not with me right now. So it makes it very very hard to synchronize the things. It also actually create a very big security risk, into the shared airflow environments. Um, so like all the big organizations actually try to run into a big airflow setup where basically all their employees can actually schedule DAGs and all those things. But because each and every component parses the Python files, I can actually I can actually write some code which can actually read to the database and maybe get access to something which I should not. And it of course it bottlenecks web server and scheduler at certain point. So uh, right now I don't have exact number because it depends upon the setup you have, but somewhere around like 1000, if you go above 1000 DAGs, it might start creating issues like the web server loading may become slow, the scheduling becomes slow, and things like that. um, so the solution for that is the serialization, and serialization has been part of Airflow from a long time, but it always had some issue or other. For example, uh, pickling was there from like since I know Airflow, 2016 time. Uh, but it has like lots of issues, like it cannot pickle the complex DAGs. If you have DAGs which is depend upon the third party libraries or things like that, it has a complex data structure in it. It cannot pickle it. And also there was some security risk associated with pickling, like people can actually write some strings which will get actually executed as a Python code when it does the unpickling. Um, the simple like the second one is the simple DAG. The simple DAG is basically a it's like a simple representation of the DAG, so that processors can have it into memory, like, and so all the DAGs they have, they can represent them as a simple DAGs. It should have just that the required arguments and nothing else. The main problem here is that it might not have all the variables, like all the attributes, but I think that can be solved. But the other point is like how to share the simple DAGs across the different processes, like you have web server and the scheduler and workers. The sharing that simple DAG object across these systems would be difficult. So the last one, uh, and which is the choice here actually, is the JSON one. So all these DAGs will be serialized into JSON format, and will not be actually keeping the complete DAG as it. We just keep some of the parameters which are required to either view the DAG onto the UI or either to schedule the DAG by the scheduler. So those attributes basically will be serialized into JSON and will be stored into centralized database. And yeah, other systems can actually work onto it. Definitely for workers, you would still need the real Python code, but for web server scheduler, you don't need. In Airflow, actually, you can see the code as well of a DAG file, right? So right now, actually, it reads the basically the Python file completely and show it. But with this, actually, it can actually do the lazy loading, and it can lazy load that Python code, just like as a strings, and then show it into the UI without like really parsing the classes and all those things. So this is like the new architecture. So if you look at the left image, which is saying that uh, you know there's a DAG processing process associated with each the component. Like I would say scheduler and web server. The same code actually runs in worker also, but there we just pass on a single DAG file location, so it doesn't harm us. But if you look at the new process, the DAG processing process actually get out of the scheduler, and it actually collects the DAG, JSON, convert them into JSON, serialize them into JSON, and store them into the database, centralized database, Airflow metadata. The web server basically now don't need to read the Python files anymore. It can directly read the DAGs from the database and can show onto the UI. The scheduler can also actually, there is a different setting, but scheduler can ideally don't need to the parse file again, and it can also read the cached DAG from the database itself. So that will also actually, do a lot of speed improvements and security fixes for Airflow in general. And this DAG processing process, I believe right now runs along with the scheduler, but I think there are, ta- there are talks to get it out of scheduler completely. I think that should be possible as well. Sorry, there is another aspect I forget about it, which I have not covered here, is about the versioning. And the versioning basically like, let's say I have a DAG with the two tasks, and I added a third task, but Airflow UI will start you showing that okay, you have three tasks for older runs also, and when you click on that run, you won't find that the task has been run at all or any logs for that task because that task code doesn't exist. Similarly, if you have three tasks or four tasks, and if you remove one task, then the UI will show that okay, you have only two tasks, but you cannot view the runs logs from the DAG UI. You can do it. There are some ways, but from the main page you cannot do it. So this serialization will actually also help into solving the DAG versioning problem to it. So that each serialized time we could actually store the version number along with it, and when the task instances get created, we can actually store like which serialized version it has, and through which we can actually populate the correct representation of the DAG over the time, and don't have to rely only onto the latest one, which is not necessarily be the correct one for the older runs. So I think there is a small talk around this part as well into the Airflow Summit. Okay, so the next one is the smart sensors, and this is being tracked into AIP 17, and thanks to Yingbo Wang to working on it. So before we go to the smart sensor, I would like to discuss about the sensors. So what are the sensors? So sensors are basically a special kind of operators in the Airflow world. So they do not actually execute anything, but they hold the execution of things until certain criteria met, and once the criteria met, they make it possible for the execution of the downstream task. So they are very much used in Airflow because for various reasons, and we have lots of sensors actually. If you go into look into Airflow code, some of them examples are like the named high partition sensor, S3 key sensor, or kubal partition sensor also. And this example I showed here is like we are using a kubal partition sensor operator, and basically you are testing a partition's availability into the default schema and the table name is my partition table, and the columns we are looking for is the month column with the value 1 and 2. So if I put this task into my deck, it will keep checking it until either it passes or either it will fail after a certain timeout. So it will actually available into two modes. It's called poke and reschedule. So poke is basically a worker thread will pick it up, like Airflow workers will pick it up, and they will go into the sleep in between poke. So there is variables like poke interval and poke timeout and all those things. So it will it will sleep until the things meet or either fail. And the second is the reschedule. So here actually the worker actually reschedule the sensor task, and it will be free. But there are lots of issues with these things. Like the first one is the like very low resource utilization, like especially in the poke one. So if you're too many sensors task, lots of your worker threads will be just sleeping actually and not doing anything. And generally what happens, they are like long running processes, like it will sometimes takes hours before something actually what you think that should be there arrives. Then each worker, like each of these worker actually emits a heartbeat that okay, I'm alive. Every some seconds, I think it's configurable, but I believe it's like 30 seconds or so, 5 seconds. So they actually emit a heartbeat, and that increases load on the airflow metadata DB. And finally, like there are a lot of duplicate sensors. So what does it mean? That in general, that all the ETL jobs are written in such a fashion that they wait for certain data to come. Let's say I wait for some certain user events to kick off my different pipelines. So I have, let's say, 4 to 5 pipelines, but all are waiting for certain data to be arrived. Then only they will start working onto it. And like so, basically, I will what I know. I'm gonna put a sensor task into each of these five pipelines, and then I will say, okay, wait until this data arrives. So basically, all these five workers, like the five tasks, are like nothing but duplicate tasks. So now, like with the advent of smart sensors, I think this is already merged into master. So rather than holding on to a worker thread, we don't use like one process for each task, but it's kind of a centralized processing, to this execute this task in batches. So it also steps like it will serialize the task information into the database. That is the first step, and the second step is to use some centralized processes to execute the serialized task in batches. And then centralized process actually will take care of not executing the duplicate sensor task, and it will use some hash code to identify that okay, I have done the similar thing into the past, so I should not do it again. This is the architecture of smart sensors. So if you go with this orange one, it shows the before. If you look at it here, it basically do the start template, render template, and then pre-execute, and then it will do execute, and it will wait until it success. But if it is a smart sensor compatible, so there is a so each of these sensors actually have a kind of a attribute, uh, something like a smart sensor compatible or not. And if they are compatible, then actually they register into the sensor service, which is basically a database. Into They actually like serialize and register into database, and then this green one actually they registered into the database. And then this smart sensor is also a multiple worker. It's also multiple DAGs running onto the same infrastructure. So basically it will go and look at through the table, see all the sensors tasks which are pending and execute it, and then then it will like run again, something like that. So it will rather than each worker is doing this thing, it will do into batches basically. And you can also specify how many such DAGs you want, or uh, because if you're too many sensor tasks, you may feel that okay, one task is doing poking for everything is very slow, because sometimes this calls may be very time taking. For example, if you are maybe you're executing some hive command to identify the partitions landed or not, right? So that might take some couple of you know maybe seconds or up to a minute, right? So in that case, if you have hundreds of such tasks lined up, then it would be very problematic for a single thread to do it. So that's why you can actually specify that how many uh, such operators should exist to get it done. So yeah, I think this should actually take away a lot of load onto the infrastructure, and your worker threads should be free to do the real task and not just like to sleep ideally. This is the last topic I want to cover, the task groups, and this is tagged into AIP34 and QNU, thanks to uh, thanks to him. Yeah, so before understanding task group, would like to understand the subjects. What are the subjects? So in Airflow, the DAG concept is should be known, but the subject is basically a smaller DAG within the main DAG. Uh, so if you look at the below picture, you see that there are two operators like dummy operator and subject operator. And when you click on the subject operator, let's say section one, actually it will ask you to zoom in, and basically when you zoom into the subject, you will see there are more tasks, like these 5 tasks are there, and which is in the right image. So like you can actually group some logical thinking into subject. So if I have a big job, right, and if I have hundreds of tasks, it will be very difficult for me to understand how this deck look like. So I actually can group couple of things, like fetch some data, do something, and like which is kind of repetitive also. I can group them into subdecks. So it will make the things very clear for anybody to understand what this deck is doing. But there are lots of issues historically with the subdecks, and actually at many places, including at Twitter also, it's recommended to not use subdecks. So basically, the problems include like it launches a completely different deck and monitor it as a separate entity, and that there are lots of handling logic has been turned into the code all over, which makes it very difficult to maintain and difficult to add new features around it. And it also consumes extra slots onto the worker nodes. To solve all of these issues, task groups were introduced. So task groups are actually the alternate of the subdeg operator, and they are modeled as a tree, and then every task group has like a zero or more task into it. And every DAG is basically is having a task group. So when you create a DAG, it automatically creates a task group for you, and that is we can call it like a root task group. And these task groups can be used as like the context manager to easily create the children basically. And there is I think you can actually do multiple level of nesting also. There are subject operators, you can do only one level, but in the task groups, you can do multiple levels of task grouping. So in the example code, if you look at the example code, you will see that there is a DAG used as a context manager. Then there is a task group inside it, which is also used as context manager. Then there is another task group, and then there is a basically a Python loop, a for loop to create dummy task. So you can actually do the nesting, and this actually will be treated as like a normal task, and viewing them into UI would be much more better and easy compared to a subject operator, and that should take away a lot of pain, related to these subjects. So I think this feature is also merged into the master, so you can take a look at that as well. That's it. Thanks for attending, and you can follow me onto that. You can follow me on Twitter at the Sumit Maheshwari, and you can also share this session on any social media using this hashtag DataLake Summit as well. And thanks for joining.